about experimental probability, theoretical probability, probability distributions, and frequency tables. Now, some of those words are probably familiar to you, maybe not all of them, or you forgot what they are, but it'll all come back to you very quickly, I think. So just a reminder, a probability is the number between 0 and 1. Okay, so typically it's expressed as a decimal or a fraction, but it's usually not a 0 and it's not usually 1, it's somewhere in the middle. So 0 means it's impossible. Like the heat's going to come on in the next 2 minutes. That's impossible because it hasn't been on all week, right? Okay. Certainty, we're going to freeze in the next 20 minutes. No, like for instance, it will rain in the next year. That's certainty, right? Especially since we live in Northwest Ohio. All right, anything in between then is typically what you see. Closer to 0 is more unlikely, closer to 1 is more likely. So we're going to be looking at the probability of events. So P of events, this means probability of whatever the event is. Whether it's like pulling a blue marble, rolling a 2, flipping a head, whatever it is, that always goes into parentheses. Okay, so the probability is calculated by taking the number of favorable outcomes, meaning what we're looking for here, divided by the number of total costs for outcomes. This should not be a surprise to you. So we're going to look at some experimental probability, meaning not theoretical, meaning what should happen, but what actually happens when we conduct the experiment. All right, so here's an example. A quality control inspector samples 500 LCD monitors and finds defects in 3 of them. So what's the experimental probability that a monitor selected at random will have defects? What do you think? So there were 3 that had a defect, right? So really we're trying to find the probability of the defect. So there were 3 that had a defect out of how many? 500. You can leave it as 3. You can leave that as 3 out of 500. You can turn it into a decimal. It doesn't really matter. Okay, the air test will take either version. Next one says, if the company manufactures 15,240 monitors in a month, how many are likely to have a defect based on this inspector's results? Okay, so we just need to take that probability, which we said was 3 out of 500, multiply that by 15,240. Again, you can leave that as a decimal, whatever you want to do. I had 91.44, right? So 91.44. Mathematically, we'd round down, but you can't have more than, like, you can't be a 4400th of the TV be bad, right? So a lot of times in reality, so in real world, you would say approximately 91, 92 of them are going to be bad. Now, all the ones that are this basic on the air test that I've seen come out to a nice whole number. So you don't have to worry about how to round it. Okay? I would say if you did come up with, usually what they do then is accept the range as well. Okay? So I would say between 91 and 92. Is that okay? All right. Next question. So the park has 538 trees. You choose 40 at random and determine that 25 are maple trees. So what's the experimental probability that a tree chosen at random is maple? We'll start there. So what's our experimental probability? 25 out of 40 is our experimental probability. Good. That's a maple tree, right? Good. So now, how many trees in the park are likely to be maple trees? So I just need to take that probability and multiply by 538. Approximately 336, 337 trees, however you'd like to count that, right? Is that okay with everyone? Okay. So theoretically is what happens when you're looking at not the experimental, but what should happen, not what actually does happen. Okay, so we're going to look at theoretical here for a minute. So first of all, the probability of rolling a 3 is expressed as P of 3. So the probability of rolling a 3 of a 6-sided dice is what? 1 out of 6 dice, right? theoretically, that's what should happen. Doesn't mean it's going to happen. Right? I could roll it 6 times and never get a 3. Okay, so what I want you to do on the next page, you actually have, I want you to look at these two kind of together. Okay, so the top two together. You're going to want to fill out this table first. So I want you to, if these are, this example, if I had 2 dice, if I were to roll a 1 and a 1, what would be the sum of my rolls? 2. If I roll 1 and a 2, my sum would be 3 and then 4 and so on, right? So fill out this table first. So take a second, fill out this table. All right, so once you have your table, now you can answer these questions on the slide that's on the left there. So let's find the indicated probabilities of rolling 2 standard number cubes. So what's the probability of rolling a 7? How many different instances did I have a 7? 6 times out of how many? I have 36 total options, right? So it would be 6 out of 36. Again, you can leave it just like that. You can turn it into decimal. You can simplify, but in the end, it doesn't really matter. Okay. How about probability of rolling a 9? That was 4 out of 36. How about the probability of rolling a 2? 1 out of 36. Only one way to do it. And then how about probability of rolling a 13? It's 0, or you can write 0 out of 36 as well. It doesn't really matter. Because it's not possible. Is that idea okay? That should all be reviewed, correct? I'm trying to go fast, so I'm not torturing you. We're okay? All right. So the next thing we're going to talk about is something called a frequency table. Really, it's just a collection of our data. It's a table of the number of times something happened when we did an experiment. Okay. A lot of times they refer to experimental probabilities as relative frequencies. Frequency just means the number of times it happens for that experiment. That's all it means. It's the exact same thing. So for instance, this is a relative frequency table for a survey that was conducted for students' music preferences. Okay, so I want to know what is the relative frequency or the experimental probability. This was an experiment, right? So what's the experimental probability of rock music? So we have 10 people who like rock music, right? But we also need to know a total. So we got to figure out how many people took our survey. Anything, add them up. 40? Do you have 40? All right, so we have 40 people take our survey, right? So the probability of rock is what? 10 out of 40 or 1/4, however you'd like to write that. Good. How about the probability of hip hop? That it was 7 out of 40. That's a relative frequency table. Okay, so a fancy name for something you've seen a lot before. Is that okay? All right. Here's another experiment. It says they conducted an experiment by tossing 3 coins one after the other. Using the results below, what's the probability that exactly 2 heads will occur in the next 3 tosses? So we're looking for anyone who had exactly 2 heads. 2 heads here, 2 heads here, 2 heads here, and that's it, right? So how many times did they actually come up with 2 heads? 7, 6, and 2, that's 15. There are 15 instances of that happening. Maybe I worded that poorly. Does that make sense? We had 15 instances of that happening. And how many experiments did we conduct total? How many attempts did we make? Maybe 50, right? Okay. So it's just 15 out of 50. or 0.3 if you want to turn it into a decimal. Simple enough? Okay. Says the student conducts a probability experiment by spinning the spinner shown. Using the result in the frequency table, what's the probability of the spinner pointing at 4 on the next spin? So theoretically, it should be 1 out of 4, right? But they want to do it based on the frequency table. So our frequency table for 4 is 18. So how many spins did we do overall? 100. So what's the probability? 18 over 100. All right, one last term then for you. A probability distribution just means we take that frequency distribution table and we put the probabilities right next to it. And like they keep coming up with all these fancy terms, but it's really the same thing we've been doing over and over and over again. Okay, so we're just putting the probabilities with that, even it's the same thing. So here we go. In a recent competition, 50 archers shot 6 arrows each at a target. 3 archers hit no bullseyes, 5 hit 1, 7 hit 2, 7 hit 3, 11 hit 4. Okay, so there's a whole list there. So what's the probability distribution for the number of bullseyes each archer hit? So let's start filling this out. So the number of bullseyes hit, we have anywhere from 0 to 6, right? We have 0, 1, 2, 3, 4, 5, 6. So our frequency is just how often did that happen? So how many people hit 0? 3. How many people hit 1? 5 hit 1. 7 hit 2. 7 hit 3. 11 hit 4. 10 hit 5. And 7 hit 6. Now we know there are 50 archers there because it told us right in the beginning, right? But if we didn't, we could add up all of our frequencies. So the probability distribution here is just going to be 3 out of 50. 5 out of 50. 7 out of 50. 7 out of 50. 11 out of 50. 10 out of 50. And 7 out of 50. Is that right? All right, one last problem. One last problem like that. It says on a math test, there were 10 scores between 90 and 100, 12 between 80 and 85, 15 between 70 and 79, 8 between 60 and 69, and 2 below 60. What's the probability distribution for the test scores? So let's think about our categories first. We have between 90 and 100. We have 89 to 90, 79 to 70, no, 70 to 79. 89. Let me try and see it. We had 90 to 100, 80 to 89. Here we go. 70 to 79, 60 to 69, and below 60, right? Those are our categories. Yep. All right, so now let's look at our frequency. How often did it happen? So how many do we have between 90 and 100? We had 10 between 80 and 89. We had 12, 15, 8, and 2. All right, now how many people took our test? 47. Good. 47. So what's our probability distribution here? We have 10 out of 47, 12 out of 47, 15 out of 47, 8 out of 47, and 2 out of 47. Is that okay? All right, so for your homework, I have some practice problems for you just like this. I know today was all review, but we are going to build on this. Okay, so it does get a little tougher as we go. But we needed that foundation to start with. phone and can't paper.